The main aim of this presentation is to create an assembly of Plummer block. Let us create a new assembly document. To create a new assembly document, click New in the title bar menu and select the default assembly document. Let us insert the first part. To insert the first part, let us browse under Parts Assembly to insert of Begin Assembly Property Manager to select the part. Click anywhere in the graphic window to place the part. Always remember that the first part that you inserted is always fixed. If you want to move the part, right click on the part and you can select float. So now you can move this part anywhere in the graphic window. Click show and hide option and select origin. I want to have a coincidence relationship between the origin of the part and the origin of the assembly. Select the origin and select mate option. Then the origin is already displayed here. Select the origin of the assembly. So you will have a preview here, and just simply click coincidence and see that align axis is toggled on and say OK. Let us insert the remaining parts. So click insert components and we can browse the remaining parts. Say cap. So just click on the window to place it. Then choose the bearings. So here the bearings are actually the bearing is represented as two parts. So this is the part 1 and this is the part 2. Let us add relations among the existing parts. So first I want to add relation between the base and the part 1, or you can say bearing brass 1. Move the bearing brass 1 and just rotate it so that you can have relationship between the snug and the hole. So let us select the surface area of the snug, curved surface of the snug. So just I want to select this area and say mate, then zoom out. So again zoom in and select the surface area of the hole. So now I want to have a relation, concentric relation. So let's select this and say OK. Select the circular edge of the bearing brass and the circular edge of the base, and you can apply concentric relation and say OK. Let us have relations between the bearing base 1 and the bearing base 2. So select the circular edge of bearing base 2 and the circular edge of bearing base 1, and you can choose either you can go for concentric or coincidence. So I want to select, say, coincidence and say OK. So if you hold brass 2 and if you move it, no, it is still rotating, so it is not completely constrained. So I want to just select this surface. So just pick it, and I want to select this surface, and I want to apply coincidence relation and say OK. Click OK in the mate property manager to apply the mates, and just rebuild the model. So if you see here, so there is no negative sign in the parenthesis in case of both bearing brass 1 and bearing brass 2. That means it indicates they are completely constrained, and it's similarly the base is also completely constrained, so they can't move. So let us define relations among the cap and the base. So let us move this. You can rotate it. So just I want to rotate the part. So let us pick this circular edge and circular edge of this brass. So just click mate and pick the circular edge of the cap and select concentric and say OK. So if I hold this cap and move, so it is still rotating, so this is not completely fixed. So what I'm going to do is I want to select this face and the surface, and I want to apply coincidence relationship and say OK. So rebuild the model. If you see here, there is a negative sign in the parenthesis in front of the cap, so that means it indicates that the cap is not properly constrained, so it can still move. So just I want to hold the cap and see whether it moves or not. So it is rotating, so it is not properly constrained. So let us select the curve surface of this hole, say mate, and the curve surface of this hole, and let us choose concentric option again and say OK. So close the mate property manager and just rebuild the model. So in the feature measure tree, you can see that all the parts are completely constrained. Let us insert bolts and nuts. So go to, just click insert components, browse and select bolts and nuts So I want to select all the items at a time, so just select them and say open, and just click on the graphic window to place the paths. Now I want to add relations between the bolt and the base, so you can rotate. So select the curve surface of the bolt and say mate, and the curve surface of the hole, and just pick concentric and say OK. So if I hold this bolt and move, so it is moving in the vertical direction. So I want to constrain it such a way that, so I will select this flat surface and I will pick this surface and I will use coincidence relation. So pick coincidence relation and say OK. So this bolt is not still is completely defined. So what I'm going to do is I want to select the flat surface, this flat surface, and this flat surface of the hole, and I want to select parallel mate and say OK. So now, so this is completely fixed. I want to insert the washer first. So select the curve surface, or you can select the edge, and you can pick the curve surface of this bolt, and you can define, say concentric, and say OK. So if I hold and move this now, so it is moving. So let's try to fix this. So let's select this flat surface and this flat surface and say coincidence, say OK. Apply relations between the bolt and the nut. So select the curve surface of the nut and the curve surface of the bolt and use concentric relation and say OK. So if you see here, this can rotate and as well as it can move along the y direction. So let us fix. So let's select the flat surface of this nut and the flat surface of the washer and say apply coincidence relation, say OK. So if you see here, still this nut is rotating. So let's select the flat surface of the nut and the flat surface of the cap and apply parallel relation, say OK. Let us fix the second nut. Select the curve surface and the curve surface of the bolt, say concentric, say OK. This select the flat surface, again the flat surface of the second nut and say coincident, OK. Still it is moving, so let's select the flat surface and the flat surface of the cap and say parallel and say OK. So here we we, we fitted the bolt and the nut. So instead of inserting a new set of bolt and nuts, what I'm going to do is I want to mirror the existing bolts and nuts. So let's close this mate property manager. Then you can choose I think the right plane is perfect for us. So I want to select mirror components. Okay, so for mirror plane I want to pick the right plane, and the components to mirror includes the bolt, nut 1, nut 2 and the washer, and say OK. So I'm finished with assembly. So let us create an exploded view for this assembly. Let us create an exploded view of the assembly. So select exploded view. Now select the first set of the nuts. So select the nut, hold control and select the second one, and you can move along Y direction, say of about 250 mm. Next select the second set of nuts. So I want to select this, hold control, and this one. So again move along the Y direction of about say 225. Select the washers, hold control and move along the Y direction, say 200 mm. So now select the cap and move along the Y direction of about 150 mm. Pick the top brass, move 50, say 80 mm along X, and say 200 mm along X direction. So pick the second brass, move say 100 mm along Y, and $200 along X. So now select say bolt 1 and move along Y direction. So just pick this and hold the arrow, so I'm unable to pick that. So again select the bolt, okay, and move along Y direction similarly. So select the next one and move along the Y direction. So in this way you can create the exploded view, and say you can close the exploded view property manager by just clicking OK. So you can just say, you can just press F to fit all the paths in the graphic window, and you can save the assembly file.